just to refresh. And in addition to that refresh from those DML languages, our primary objectives for today are aggregate functions, categorizing those aggregate functions, logical operators, and let me make sure. Yeah, aggregate functions, categorizing those aggregate functions, and logical operators. So to start out today, let's get into a refresh from our conversation from our last session. So last session, we focused on those DML languages, that data manipulation language, those primary components that you do when you navigate within SQL. And those four DML languages were select, insert, update, and delete. And primarily, it's good to remember that everything that we do within SQL goes back to tables. You're always retrieving from a table, inserting data into a table, updating or deleting an existing table. Select. Select here is where we retrieve the data from the database. Select. Star is a wild card. Bring me all the data. Oh, I'm not recording. Let me record this for you. Bring me all the data, all the records, all the data and all the columns from that table. Select star or your column names from your table. Insert. That is when we are primarily inserting data into a table, adding new data to that database. Like even when it comes to your weekly coding challenges, you always have that create table syntax. You create that table, and then you turn around and insert that data into the table. Insert into your table name, the columns, and the values. They have to match up explicitly. Update. That is where we are updating that existing data within that database. Update your table name, set your column equals this your updated value where this condition is met, where this column name equals John. Now, tonight, what a primary focus is, we're going to focus in on these conditions as well. So remember, like whenever I provide a function and I say where this condition is met, those are called conditions. And that's essentially data filtering. Delete from table name where this column equals John, where this condition is met. Always, anything we're doing, we are going back to a table. At our truest core, at our foundation, regardless of how complex our queries get, whether we are joining data, using case statements, aggregate functions, CTEs, views, all those things that you're going to do within these sessions, they essentially build upon these core and foundational concepts. So the way that I always look at it and the way that I approach things, like even now, is if I'm doing a query or if I get an ad hoc request, I always start from the foundation and essentially build upon what I need. I layer it. The same way I teach y'all is the way I do it, because to me, the way my brain works is no different than how you get dressed or you're cooking, you do a recipe. You add a little bit at a time until it makes sense. And that would eliminate you from becoming overwhelmed or just trying to see the bigger picture. It just allows you to say, okay, well, I need this and I need that and I need this. And your brain will just be able to pinpoint exactly what you're trying to get. So that's how my brain works even today. Even to this day, I'll talk through my code. I'm like, okay, well, I need this data from this table. The same way I teach y'all, okay, this data from this table, what's in here? How do I do this? What's this data type? All that, like I talk through it myself just so I can hear myself kind of know what I'm doing. So everything we do will essentially go back to these core concepts. And remember, ideally, 99.99999% of the time, this is what you're going to be doing. In your day-to-day life, you will not hardly ever have these permissions to insert data or update data or delete data, only due to privacy constraints. But I do think it is important for us to discuss them and for you to apply them like we did on the last session, so that you are aware of how to format it, what it means, what's the impact, things like that. Any questions?
Not at the moment. Oh, I guess I did have one question.
Okay.
Insert.
Okay.
Yeah, for the insert function, if you insert and that particular row already exists, does it overwrite the information there, or does it flag an error that something's already existing there? Remember?
That's a good question. That's an excellent question. Actually, when you try to insert the records into the data, insert the records into the database, and that existing record already exists, does it reinsert or does it like just skip? Essentially, it'll skip if each of your columns are an exact match. Now, if I have, for example, if I have a first name John, last name Doe, but a different customer ID, it's going to insert that record. Because technically, those are two different records, because each one of those values don't explicitly match. But if it already exists, then but let's take it a step further.
If it's a primary key?
Yes, that's what I was about to say. But it also depends on the rules of that specific table, because it will throw you an error and say, well, that customer ID already exists, because that's when you get, like you stated, into those primary keys. When you have those primary keys, only one can exist at one time, and it will throw a flag and say, due to the constraint of the primary key. It's something along that verbiage. It'll say, due to the constraint of the primary key, it will not allow you to do it.
Okay.
But it also depends on your data types and stuff, and how that actual table is constructed. Because if you create that table and you don't have any primary key constraints, it's gonna allow it to insert in there.
Okay, that makes sense. And you'll have two items.
Yes. Yep.
Okay.
And that's when you get into that data validation, making sure you have quality data, making sure that your data is able to be used, because there are times where you can get duplicates within your data set. But that's a really good question. It just depends on how that table is constructed. If they have that primary key constraint, it's not gonna let you do it. It's gonna say, mm-mm. But that's a good question. I like when you ask stuff like that, because the way your brain thinks, I can tell that you are very much so an engineer.
Yeah, thank you very much. I appreciate that.
Mm-hmm. Your brain, like the way your brain thinks when you ask stuff like that, it's just, I like that. But yeah, good question. So those are the 4 DML languages. And now let's get into logical operators. So what are logical operators? Logical operators are essentially a reference to when you get into the advanced filtering. It allows you to niche down on explicitly what your data set needs to be. And see, my laptop still beeping. And remember how I was saying how anything we do goes back to those foundational understandings that we already understand. Select whatever your columns from your table name, where this is your condition, this column equals IT, and this column is greater than salary. So your logical operators allow you to filter results based on multiple conditions, where this condition is met and this condition is met. And you build your query based on that expected output. You can have as many, it can get as complex as possible, contingent upon what the goal is, what you're doing, what you're looking for. You essentially build upon what your foundational syntax is. So we have select star from this table where this column equals IT and this column is greater than 50,000. Now, there are multiple logical operators, but the ones that I'm going to focus on for our session are and, or, not, between, and in. And the reason being is because they are the most common ones. There are others, and there are other ways to do and perform these, but these are some of the most common ones. So let's get into and. When I say select star from this table, where this column equals this value, and this column is greater than this value, and essentially means that all conditions need to be met for that data to be returned in the output. So my output for this syntax essentially is select all from employees. Give me all the data from the employees table that are in the IT department and they make over $50,000. So in a way, that would be the qualifiable ask. How many people in IT make over 50,000? And then you turn around and you quantify that qualifiable ask. Or does essentially what it sounds like it does. Select star or your columns, because whatever you want in your output, that's what you want out of your select statement. From that table where this column equals IT or the department equals HR. So give me all the data from the employees table where the department is either IT or HR. Or when I say or, I need to know that at least one of those conditions are true. It can either say IT or HR. I want both of them. And is both or all. Or is give me either one of them. Not essentially negates a condition. Select all from employees where not department equals IT, where the department is not IT. Another way that you can format this that is common as well. And instead of saying where not, you can say where department, you have the equal sign, and then you put an exclamation point like this. And it's essentially says select from the employees table where the department is not IT. If I say the column name and then equals exclamation point, they're saying where it's not that.
So it would be where department equals sign exclamation point. Okay.
Yep. And that is essentially not like that's essentially another way. So if you see that syntax written like that, or if you see, or if that feels better to you to say, instead of saying we're not department, if that feels more closely to like your language and say where department, exclamation point, equal sign, exclamation point, it's essentially the same thing.
Which one is more commonly used?
I see them both.
That makes sense. Okay.
Yeah, I see them both. I think it just kind of depends on what feels natural to that person when they write their code. I see them both. And I write them, if I have someone else's code and they start out, we're not department, I just kind of keep the same format. But if they start out with, or if they have in their code where equals exclamation point, I just follow suit too. I see them pretty commonly. And that also, that mindset also goes within next session when we talk about joins in our join statements. And I explain how people structure their code differently to where they might provide different aliases just depending upon what feels natural for them. So I just explain the concepts, and then I give you free range to kind of organically lean into the way your brain works on how to do it. But yeah, I see them both, and they both pretty much about half and half. Between. So that between syntax does exactly what it says it does. It checks if that value is between a specific range. Select star or your column names from the employees table where this column between these two values. Now, it's not uncommon to use between to check ranges with values, but also it's not uncommon. You can apply between for dates as well. Let's say you get a data request and you say, okay, well, I need to know how many people joined or signed up or whatever the condition is in the year of 2023 or in the month of March or last quarter or Q2, those type of things. That's how you would perform your filters or your logical operations to check ranges. And a big thing when you are using the functions like the logical operator is to ensure that your actual data matches the actual data that's in the table. Like, for example, if your data is formatted a certain way in that table, make sure that your code reflects it.
So like for example, like date,
Mm-hmm.
for a specific date range, we'd have to be particularly careful with how the data is formatted in the database. If we're looking for data within a specific date range.
Bingo.
Okay.
Let's say you got month, day, year. Make sure you capture it month, day, year. I mean, I'm sorry, year. You know what I'm saying? Year, month, day. However, that data is explicitly within that database, your code has to match. It has to be extremely specific. Because if not, if I say select star from employees where salary between, and I put the different format, it might not return anything, only due to technically it doesn't exist. So, yep.
Makes sense.
Mm-hmm. And so this is common in the event that you are checking a column, but you want multiple values from that column. Select star or your column names from the employees table where the department, this column in IT, HR, and finance. And the way that you structure that, you open up your paren and you list out your values. Also, make sure that you put your quotes around it to indicate that that's a string. And you put your comma between it, no different than how you would naturally write something in your natural language. If I say I need this, and this, and you write in a sentence, you're going to put a comma between it the same way. So you structure it the same way. Close your parentheses. And this output will be all the data from the employees table where the department is in any of these values. So that is common, or that's useful because it keeps your code clean. But let's say that I am looking for, here I have two. In my order, for example, I have two, IT or HR. So this syntax is going to pull IT or HR. These two essentially do the same thing, but let's say I have 3 or 4. You're not going to consistently keep writing department equals IT or department equals HR and department, like you're not going to keep writing it. So this is in the event, let's say you have 5 or 6 different values that you're checking for within a data set that has 3 million records of code. This keeps your data super clean because it allows for it to just be easily readable and structured. In the event you go back and have to look at the data or use the data or explicitly know what you're trying to capture. It just makes it easier.
Okay, that makes perfect sense. And then is it kind of similar where can and be used to search for no, never mind. It's meeting all of those specific conditions.
Yep. And has to meet all of those specific conditions. So the more you And naturally your data set is going to become smaller and smaller and smaller. Because I'm like, if think about it like this. Can you go to the grocery store for me and give me a gallon of milk? No, I'm gonna take it a step further. Can you go to the grocery store for me and give me some milk? And you walk in the grocery store and you got a whole freezer full of milk. Then they say, no, I need a gallon. So I'm like, okay, it kind of goes down a little bit. And I need almond. Okay, so it goes down a little bit. And I need unsweetened. Okay, it goes down. Every time you say and imply that condition, your output is naturally going to diminish. So that's where that advanced filtering comes into play, because it gets super specific, but it allows you more visibility into what do I need? What exactly do I need? I don't need this full data set. I only need this and this and this.
Okay. Okay, that makes perfect sense. Thank you very much.
You're welcome. So let me connect to the database. And tonight, it's not nighttime. It is not nighttime. It is not nighttime. So it's the daytime. So today we are actually going into the healthcare system DB. And if you want, let's actually walk through the architecture again as well. Hold on, let me get rid of this. Okay. So this is our database. This over here is our Object Explorer. This is a relational database. Remember how we have different types of databases. And essentially, what the core difference between those types of databases are the way that your data is stored. So here we have our Object Explorer here, and all of our data is stored in tables on-prem, real tape, like the tables are on the device. Whereas if you are in a cloud database or a cloud infrastructure, it's outlined the same way. However, your data is not stored on premises, it's stored in the cloud. So here we have our server. We have our databases here. And these are our databases. Ideally, when you do your projects or when organizations store their data, ideally they try to keep like all the data within the same database to be relational. However, there might be times to where you have to join tables from multiple databases as well. But that's just like depends on how the organization stores their data. So here we have our databases. Today we are going within the healthcare system database. So I'm expanding that one. And you see all of your tables here. You can expand all of your tables. So these are your tables. And in the interim, you naturally do your data investigation. You go in there and you're like, okay, well, these are the databases. This is how the data is stored. These are the data types, because you can click on the tables and see your data types, see your primary keys, things like that, like you mentioned earlier. Your primary keys, your foreign keys. You can see all of that data type within there. Now, you do your data investigation. And did you have a question?
Okay. I was trying to follow along.
Okay.
Well.
Now, the way that we are going to facilitate essentially these sessions and going forward is I'm going to let you drive. I'm a guide like how I did. And especially since we have our one-on-one session, I'm going to let you drive. And in the event that you need to share your screen or talk through what your code is doing, you're more than welcome to do so.
Okay, sounds good.
So we are for sure, at least starting out, going to go within this healthcare system database. And in this healthcare system database, how many tables do you have in here?
So for me, I have
okay.
5.
Mm-hmm. And tell me the relationship between those tables.
So for appointments, is appointment A is a primary key.
Appointment. Which column?
So maybe can I share my screen?
Yeah. And I'm gonna pull you on my big screen so I can see what you are doing.
There we go. You know if you're able to see it.
Yeah. Okay, perfect. Perfect.
So this is these were the 5 keywords that I saw.
Yep.
And in terms of what are the relationships,
yep.
I was looking at what the primary keys and the functional keys were between each of them.
Mm-hmm.
To see overlap, and I would assume that the overlap between them would be those keys.
Yep. I love the way your brain works.
Oh, thank you.
I do.
But let me see. Looks like that's tricky.
And then it might help. No, not that database. Close that one up. That's another database. Go to your columns and expand those as well. Right above your yep. And that helps as well.
Oh, I see. Okay. Oh, maybe that's why this one looked different.
Oh, yep. But to know your keys, that's valuable as well, because that's where those data dependencies come into play. Because that data essentially depends upon that other data in order to be inserted. Like, for example, the question that you asked earlier goes hand in hand with what you're looking at right now. Because when you look at so we are in your prescription table. So it's telling you that that PK, that prescription ID, is your primary key. That's the unique identifier for that table. However, it's also the foreign key in that doctor table and that patient table. See how your keys down there, it tells you where it is.
Okay, I see.
Yep.
And then.
Yep. Now that's when you get into your data dependencies. When you are navigating the analytic landscape, your primary focus is not just data. Your primary focus is clean data and understanding how that data set depends on the other data set. Are there any dependencies? And if so, what are they? And that's just something to have within the back of your mind when you're navigating the space, because you have to make sure that if you are performing an analysis, that your analysis is done on quality data. Trash in, we got a saying in analytics: trash in, trash out. If your data is trash, your analysis is going to be trash. So the fact that your brain is already working to see those dependencies and understand how each of those relate to the next, that's an amazing skill to have, because it's a very overlooked skill. Because even when I have conversations with people that are not within data, they think that lots of data is the goal. We got so much data. And even when you navigate your day-to-day life and you think about how much data you give out and how much data you use, even when in the event that you are like in a grocery store or you're at a gas station, they say, well, did the clerk smile to you today? Did you have good customer service? That's all data. And you're pushing that data out there, and the average person, they think I'm just answering a survey, but they're taking that data and they're analyzing it. So if 500 people come in this store today And that's just one store out of millions. Think about how much data that is. So the goal is clean data, especially in the event that you have a data source that is user that comes directly from the user. For example, you're on a website and you key in your own information. I might misspell something the way that I might write my name lowercase. I might, whatever the case is, because every person does things differently. But that data that you're putting in there goes into somebody's database somewhere. And it's being recorded, it's being tracked, and they have all this data. But just because we have this massive amount of data does not mean that it's useful. It could very much so be trash. It could very much so be somebody going in there just typing in numbers, whatever. It could very much so be that. So the fact that your brain is working towards creating those relationships and understanding those dependencies, that's a strong skill to have, because that's when you get into that high level data investigation. But you take it a step further and say, okay, so what are the dependencies? Is this quality data? And quality data, and not even to get on a tangent because we started back in a minute, but quality data is a huge need within the analytic landscape. One of my roles specifically focused on ensuring that the data was quality. And I did that for 2 years. And what that looked like is doing exactly what you were doing now. Okay, so does this exist here? Does this exist there? Is it saving characters? Those type of questions to ask yourself. And it was essentially a role. And the more I see now, I see a lot of data analytic roles that are focused on data quality, because we got so much data, but it's trash. So that's a very good core skill to have.
Thank you. And that makes perfect sense. Thank you for that explanation.
You're welcome.
That helps. So let me see. It looks like patient ID, it's relational, and patient ID is coming up again.
Yep.
First name, last name, maybe as well. Because it's first name of the patients is appearing here, and then first name. Oh no, that's the test name.
Yep.
Doctors.
Yep. So we do have a first name, last name within the doctor table, and a first name, last name within the patient table. But that is for what you think is for the doctors or for the patients. Those aren't related. The way you would have to relate that doctor and that patient is, let me see. So we got the doctor ID. When we get into our joins next week, you will actually have to join one table. You would have to join 3 tables to get their name. Because let's say if we are trying to figure out, and look at putting the buggy before the horse. But anyway, if we're trying to figure out what patient goes to what doctor, we would have to join the doctor table to the appointment table, and then join the appointment table to the patient table.
Okay.
Yep.
Both of them link up.
Yep.
Okay.
Like you would have to use it as like, okay, well, but yep.
And then when we join the tables, does it create or form a whole new table?
No.
Or does it just pull information from both of those tables?
Yep.
Output it?
Yep. That's exactly what it does. When you join, you're going to join those tables and you'll create a new output based on the data that exists in all those tables. Because with the way data is stored is, with this session, we're only going to focus on one. But the way next session, we will get into joining tables. And the way the data is stored is, your data can be stored across multiple tables. And your goal is to, just because it's stored across multiple tables, but you still need to analyze or create a relationship between 2 of those tables that depends on, the analysis of this data and this table. You still have to join those together. And it creates a new output. But not only is that beneficial for SQL, it's also beneficial. Power BI does the exact same thing. They do like In PBI, it's called merges. You'll merge those two data sets. But in order to merge them, the way that your brain is working and the data investigation that you're doing, it has to be applicable to Power BI as well, because you still have to create those relationships. So that skill goes into analysis all the way around, from writing your code to building out your dashboard.
The Power BI is the Power BI over. Uh-oh. This one is it?
Yep.
Is it optional?
Is it what?
Can I use this one?
I don't have any data in there yet. It might be. Click on it. Let's see real quick. But I didn't put any. I don't recall putting any data in there. But it's definitely when I downloaded these VMs, I did download Power BI as well on there. But that's exactly what it is. And when you do your data sets within PBI, it's a Microsoft tool as well. So you have to merge that data based on relationships between those two data sets. Yeah, it ain't no data in there. But when you do your dashboard and when you go and when you look at your data, you have to, and if I want data from this data set and that data set, because in Power BI is essentially data sets, but that back end to Power BI, open it up again. Let me show you something real quick before we get back in our session. I nerd out about this, darling. Go right there. Now, you see how you can select the data source or start with a blank report. You can connect SQL Server directly to Power BI.
Oh, yeah.
So that is where that reporting and analysis comes in. Also, a big part of what we talk about within our sessions are we create views. We do a lot of things that are more advanced. And when you think about in a grand scheme of an organization, when they are using dashboards and things like that, by the time that dashboard is built and HR is using it, workers' comp is using it, whoever is the consumer of that dashboard, they see the pretty put together dashboard. We see what you're learning now. And when we connect SQL Server directly to PBI, we have to aggregate and clean that data so that when they refresh their dashboard, it shows up to exactly what they need. We control it.
Oh, gotcha. Wait, so the refresh of the data, so once it's refreshed or updated within SQL Server, it's automatically pushed over to Power BI?
Possibly.
Okay, that makes sense.
Yep, quite possibly. Or if you create a dashboard within Power BI and you're connected to SQL, the analyst or whoever the consumer is of that dashboard can click refresh and it'll refresh the data.
Okay.
But that can, yep, they have that capability due to their connection. You can connect your dashboard directly to SQL Server. You got to log in with your server name, everything. And when you connect to that server, you tell it which tables or which views to connect to. And when you see how when you log in, so you connect and you tell it which tables or which views, and we'll get into views in our session 4, it connects to. And within that, that's what populates that dashboard. So it's all connected.
I see. Okay, that's very interesting.
Yep.
I did use Power BI, but I only ever used Excel as a data source.
Uh-huh.
And like I would update the Excel file, but then I used Power Automate to automatically refresh it every day. I think at like 5 o'clock or so. Because I didn't think the person that was receiving the information would know to refresh it. Or would think to refresh it. But that's very neat.
What were you using to populate your Excel? What data source was that like what was that connected to? Or were you manually updating the data in Excel or like sourcing it from somewhere?
So for Excel, what I did was I received an extract of data,
Oh,
of label data, of what sites printed which labels and what quantities of them as well. And then I was looking at how many reprints were happening locally.
oh,
So I know the Excel file that I had received was a SQL query because I know
oh,
that they use SQL in the back end of our labeling system.
yep.
And so IT pulled that for us. So then I took the Excel file and then I visualized the data in Power BI for my managers because they wouldn't want to see a whole Excel file of just
Exactly.
numbers.
Right.
Yeah.
And that's really good experience because the way that I teach is like I always hound in on the fact that you're the analytic professional. Who you are providing your analysis to, they're not. So the same way how you took that data, you got to extract data extract. You then actually were performing as an analytic professional when you went and created that dashboard and connected to that dashboard. You were the analytic professional and you took it and you took that massive data that's unstructured. If I look at this, I don't know what my aggregate, which is what we're going to talk about today. I don't know what my aggregations are. I don't know what my total counts are. I don't know anything because I have a data set or an Excel spreadsheet with hundreds of thousands of records of data. So that's not useful for the business or for someone that needs to look at a dashboard or have insight or visibility to pertinent data points. That's not useful for me. So what you did was take that data and you made it useful. You were providing that source to someone that is not interested in making that data usable, making that data clean. You made it clean. And when you think like when you're able to look at things and relate it back to what you've already done or the work that you were doing it, you were connecting to Excel, you can connect to SQL Server, you can connect to other databases. I've connected to proprietary software, all type of things directly in there and formulated my data, gave my Power BI or my dashboard access or visibility to certain views, which we'll talk about certain views or tables, and did my analysis or a store procedure. You have store procedures that populate dashboards, all type of things. But when you have that dashboard and when you create it for the consumption of someone else, they don't care about 20,000, 50,000, a million records of data. They want to know what the average amount of this was today and yesterday and a week ago and be able to compare and create a baseline and what's the trends. They want to know that. So the fact that you were already doing that work and your brain already was like, oh, so this can also connect from Excel, but this now could also connect to SQL. That's exactly right.
Yeah. Oh, I thank you very much. I appreciate that.
Mm-hmm.
Sorry, I'm getting us derailed.
No, no, I will nerd out about this, darling. This is my thing. This is my thing. But I like the fact that you are creating relationships, not only with the data, but you're creating relationships between the work that you have already done. And when you're able to take things, and that's just like with us when we learn anything, when you're able to take things and relate it back to something that you already know, it's easier. It makes it real. And it takes it from abstract or something that seems far away or something that seems just unrealistic to like, oh, that's what I was doing. Oh, that's what that was. Oh, those are the type of things that accelerate your understanding.
Thank you. I appreciate that. Thank you. And I yeah, trying. But
Yeah.
okay.
So you are on my big screen. So you got you've done your data investigation. Now,
Yes.
let me I am going to present a use case to you. Where my code is? Okay. I am going to present a use case to you. And the first thing that you need to do when you create your use case is, okay. The first thing you need to do is, when I give you your use case, is to do your data investigation, see which tables answers this, and then see which columns within the table answers it. So the first request that I have is, and I'm going to type it in the chat for you to have as well. I'll type it first. Okay. So I need the patient ID, the test name, the test date, and the result of all patients who have had an abnormal cholesterol test.
So patient ID, test name, test date, results of all patients had abnormal cholesterol. Okay, so now in this screen, how do I do new query?
You can do new query, or the way that I do it is I right click on the table and then select top 1,000 records.
Oh, I see. Okay. Oh, I remember that.
Yep. And that does two things. Firstly, that automatically ensures that you're connected to the right database, because since there's multiple databases in there, you have to essentially make sure that you're connected to that right database. And then secondly, it'll also give you visibility to how the data actually is housed within the table.
Oh, I see. Okay, that makes sense. And I think it's medical tests. That I've seen. Okay. So then, if I'm looking for the patient ID test, I could do. Not looking for the test ID number.
Right. Oh, I ain't said. I'm sorry.
So we're looking for a patient ID, test name, test date, and the results of all patients where hold on. I'm gonna go back to my cheat.
Oh, you know what? Let me share my screen. Let me share my screen so you can see. You don't have to. You don't have to do that. I'm actually gonna share my screen so you can see my logical operators.
Oh, perfect. Okay.
So there you go. And you can stop sharing. You can stop sharing because I know it makes it small. And then when you're ready to share, we can walk through. But you definitely can see the syntax.
Okay. Oh, perfect. Okay. So I'm looking for it where where test name equal test name or test name equal and the test result or result.
And I'm gonna write my syntax with you.
Okay, I think I got it.
Okay. Okay, let me see. Perfect. Perfect. Now, walk me through what your code is doing, and then I'm gonna present the next use case for you. I didn't even get a chance to do mine.
Oh, so I was looking. So I selected the columns patient ID, test name, test date, and the results from the system healthcare database. And I was looking specifically for conditions where the test name would equal the cholesterol test, and the results equaled abnormal, and then looking for both of those conditions.
Perfect. Now, can you provide me a list of patients that have had a cholesterol test, an ECG, an abnormal cholesterol test, ECG, and MRI? I'm writing in chat.
Oh,
and let me share my screen so you can see my code. See the logic, because you will have to change which logical operator you're going to use for one. But yeah. So I am writing the updated use case in the chat. I cannot spell cholesterol.
You know, it's funny. I struggled. I was glad that it appeared on some of the ones in the top.
Yeah.
I was like, okay, that's a gonna spell it.
Yeah.
So, like, as you put that in there, if I have data that is unclean and test name, like cholesterol is maybe cholesterol underscore test or cholesterol just in the name, but doesn't have the word test, would it still return it or?
Mm-mm.
Okay.
Yep. That is when you get into, that is when you would have to update the data. That's when they update this column to, set this column to where this condition is met. You can update it, or another way that you can get around something like that is to actually manipulate that string. And we're going to talk about the manipulation of string functions next session as well.
Okay.
Yep. Those are great questions though, because there might be times there might be times where you have to do that because you can manipulating a string function does not impact the way that data is actually housed within the table.
That sounds very good. Thank you very much.
You're welcome.
Okay, abnormal test. Cholesterol boost test.
Oh, and another thing, make sure that you're documenting what your code is writing to at the top.
Oh, that's right. Okay.
So you can keep up with your best practice framework. I thought about that a minute ago and I forgot to say it because I had started writing my code. You wrote it really fast though.
I'm gonna copy and paste it into like
Okay.
So,
Perfect. Okay.
I can show you what I have so far.
Okay.
It's erroring.
You said it is erroring?
Yeah.
Okay, let's walk through it then. I'm gonna put you on my big screen so I can see better what you're doing. Okay, so what's his name? Okay.
So this one runs.
Okay.
Where for the test in between this, and I ran it.
Yeah.
But I'm trying to put in like the additional where case.
Exactly.
So do I do like another where?
Nope. You had and you put your code back up there and let's walk through because your code is like put it on line 8 just so we can see it all at the same time. But it will work. Okay, there we go. Now your code is about 90% correct.
Okay.
You use the appropriate logical operator. The only difference is when I say and you have to specify which column after and. You have instead of instead of saying in between column name, say and test date between.
Oh, I see. Oh, okay.
Because when you think about it, I'm telling you, use this column between these values. Now, let's get into this error. It's saying that your date is incompatible with the integer. Now, when you look at your data type for that test date, it is a date data type. However, the way you have it structured in there is like an integer because you didn't specify the string. So essentially, the only thing you got to do is specify that to be those dates to actually be a string. But other than that, it's right.
So it's like this.
Yep. Yep.
Oh, okay. Okay. So and test date between. Okay, man.
Exactly. But the fact that like it's stuff like this is very like I'm okay with it. Okay. Like your code, first of all, line 1 through 7 was absolutely correct all the way around. Line 8 was like 90% correct. It was just when you think about it, think about how you logically in your natural language explain something. And I need to tell you what you're about to filter and this column between this. Like you essentially are telling it exactly, but that's it. You just have to switch them around.
Okay. Nah, that once you explain that made perfect sense.
Yep. Good. Yep. Any questions?
No, I'm gonna copy it to my notepad.
Okay.
Or my notes. Oh, that's not the right case. Thank you so much. I really appreciate it. You're an excellent teacher.
Thank you. You're an excellent student. You are an excellent student.
Can you tell my mom that?
I'm sure she know. I'm sure she knows. I'm sure if she know you her whole life, she know that. I'm going to give you one more use case to perform those logical operators, and then we will go into aggregate functions.
Okay.
Okay, so I need a data extract of all appointments that were canceled in 2024.
Okay.
Because it's like, are people coming to the doctor? Or are they trying to like sit around and roast chestnuts?
Would you need the reason for it as well, or no?
No reason. Oh, you can. Yeah, let's keep the let's get a reason as well. Good question, because I think that reason will help us even if we were to analyze the data. What were they coming in for anyway? So yeah.
Do you mind sharing the logical?
Oh yes, I'm sorry. Thought I was.
No, you're perfectly fine. I'm gonna have those memorized.
You don't have to memorize it. What you do, darling, what you're doing, you're applying it. That's the goal. Don't try to memorize it. Apply. After a while, you're not gonna have to use anything anyway. But did I type the use case? Yeah, I did. Okay.
I got it.
Okay. You may stop sharing.
Yes, please. And I'm gonna share my screen.
Okay. Now I need to extract all the patients that we canceled in 2024. Okay, come through documentation. Okay. Perfect. Now, let's take it a step further. I'm going to have to share my screen because there's one other thing that I wanted to show you in addition to our logical operators and our aggregate functions. I also wanted to show you how to order your data. So I can share my screen and you can apply it to yours if I can see it. Okay, here we go. Okay.
I wanted to ask, why is status blue, but
Oh,
the other?
let's talk about that. Let's talk about that. Let's talk about that. Good call out because I need to highlight that as well. So, do you remember in our last session when we spoke about reserved words? And I was explaining that a reserved word is essentially what your system understands to perform certain operations. It's no different than how you were to go to a wedding and y'all have reserved seats. This seat is for this person. It's no different than when you have a conversation or when you have a dog or something and you like, okay, let's go for a walk. And you say walk and your dog like, let's go. It has the expectation of something happening. Those are reserved words. Now, when you select your top 1,000 records from, I'm going to share my screen. Oh, I can just pull it over. When you select your top 1,000 records, how you do directly from your database, it's going to automatically select top 1,000. This limits your data. It only brings back 1,000 rows, but it's going to also provide those square brackets around each of your columns. The purpose of those square brackets is to support that in the event that these columns are actually also reserved words, this is not a reserved word, this is the actual column. And I know that because the user selected the top 1,000. So when I need a column name that is also happens to be a reserved word, like status. Status is a reserved word for the database that checks the status of how things are running. That's when you get into like that DBA word. However, your status is also your column name. So that's why it's blue like that. Now, if you were to go and put your square brackets around it, it would cancel out like, okay, this is a column. This is not a reserved word, so treat it as such.
Would it be best practice to always put brackets in between your columns?
You can, but if it's not a reserved word, your code will compile anyway. But the way that I do it is if I start out doing a certain thing, I just keep that consistency up throughout my code. I just like the way it looks.
Okay, no, that's fair. That makes sense.
Yep.
Okay, that makes perfect sense. Okay, sorry about that.
No, you're good. That's a good question. And thank you. That's a good call out because that's important to know because there are times, even as we navigate, like in real life, I had to do something. What was it? Oh, so yeah, this was early this week. I had to grant permissions to a certain user. And then the way that it was set up is I